The MEL-40 has evolved over many years to become a very versatile laser machining system. You can use it for short repair, you can use it for basic laser patterning of ITO, you can do some silver patterning using it. Cutting, drilling, micromachining has been performed with it, even resistor trimming and some marking. Today I'm going to show you a brief overview of the system and how to use it for cutting shorts. Main system over here, your basic power and emergency off functions to it, your beam size and shaping functions to change the spot size to it, illumination section to it, turn the light on for the viewing, workstation light, laser power supply, the power supply section for the laser section, the Q switch for the laser which does all the pulsing to it. These are pretty much, you set it up for a given recipe and then you leave it alone. And then we got the main access doors, we got two bifolding doors, interlocks for both doors, so as soon as you open up the doors it closes the shutter to the laser, so there's no laser exposure when you're in here. Viewing monitor. Right now, once we put a part under there, you'll actually see what you're cutting and where you're cutting. Computer screen has the active display here that shows you what commands you've typed in or the program that's run. Then it has jog window screen over here for changing your jog speeds, your direction of moves. You can either use the mouse to point and click on these, or you can use the arrow keys to move those around. Then the interactive keyboard screen with function keys that we set up with predefined programs, so that basically if you want to run job 1, you press F12. You want to run job 2, you can press F11. Here's the internal guts to the system. Back section is your laser. So you got rear mirror, aperture, Q switch, does the pulsing, the lamp, pulse station of the heart of the laser that generates the laser power, front mirror. Laser comes out, turning mirror shoots it over, turning mirror shoots it through. Using the two turning mirror system makes it very easy to line through this chain here. This is the beam expanding telescope that actually controls the spot size that you saw on the front panel knobs. That basically changes the separation between these. Then we shoot the beam down inside the overhead moving stage. The stage has pentaprisms inside here, so that as the stage moves, the beam actually tracks that movement and everything stays square, so you don't lose any alignment to it. Through the lens viewing system here, this is the camera that actually looks straight down through the laser path and sees exactly what the laser sees, so you can use that for alignment and monitoring as you're doing the cutting. These are basically just the motor controllers for the XY stage motors. This is the illumination source for the top illumination. So this shows you the overhead XY stage that moves the beam around. So you have X and Y in here and then the Z on the bottom. It's got both manual focus, or you can go through and do it through the keyboard. So if you watch the illumination, the orange round spot in the middle there, we'll move to the left here. And that shows basically the overhead beam position are moving across the part there. If we had a part in there, that's basically how we cut the defect out. So this just shows a typical ink mark that we went through and we made a defect on there. The ink mark is now centered on that round orange illumination zone. That gets the defect in the center of the field of view, so hopefully when you switch to the TV screen, you'll be able to see the defect and then simply position on that. Removal here, and this would be a defect zone in between. So we're basically going to go through and connect these points and cut across there and literally cut out whatever defect would be in between those two. Okay, so we predefined a couple function keys for typical programs that we use for defect removal. So F12 is the first one we'll use. It loads the program, starts it, and then it prompts the operator what to do. So move to the left side of the defect using the mouse, press enter to continue. So we'll basically just click on the arrow keys to move, and we go find the left side of the defect that we'd like. We can change speeds in here while we're doing this if we want to very precisely position the pointer. This exercise will go to the bottom corner for the fun of it. So let's say about there. Then we click OK to continue. Now it says move to the right side of the defect. So now I'll move up and over. Same thing, slow it down. Fine tune it on a corner. And you'll notice that we've got a nice angle on there. It doesn't care which angle we put it in there at. And then once we set OK on the second position, it will cut back to the start position. We have this one currently set up so it's looping. So say we didn't believe that defect was thoroughly cut. We press enter, it'll cut it again. Press enter, it'll cut it again. And one could customize the program and let it do many different things like that to ensure that the defect is removed. A couple more times and it times out. So here's another typical defect removal that you might require for it. So this one's a little bit wider. So this one I put on F11. So simply to push a different button loads a different program. So we'll go find the bottom left corner. That's close enough. Press enter, go to the right corner, and we'll speed it up. So you have 3 preset speeds on here that one can easily, quickly choose from. Press enter, and now it's going to cut a box outline on this one. So if there was a defect inside there, one can isolate it. So I'm going to switch to a larger beam by changing the beam expanding knob. We can have predefined values on here that will basically tell you what spot size you'll get to. So now with the larger beam, we're going to basically go through and do a hog out. It's going to remove all the material within inside that area. So if you had a large defect and you wanted to remove the whole thing, this would be an easy way to do it. We're going to change the beam expander while we cut a straight line to see how the spot size varies. Okay, now we're going to change the beam expander while we're drawing a straight line. Okay, on the existing configuration here, we have about a 32-inch workspace left to right, which will allow us to get about a 16-inch piece of glass in there. Slightly larger if we offset the stage for one side or the other. Worst case scenarios, we remove the sides and we change them to basically U-brackets. And then we'd have to put U-bracket covers over those. That concludes the MEL-40 video demonstration for short repair. The MEL-40 is capable of a variety of other material processing applications: cutting, drilling, trimming, marking, scribing, and patterning. For more information, visit the Laser Rod website.